Hey, everybody, it's Doug Green, and I'm the publisher of Technology Reseller News. And it's my great pleasure to have with me today Roel Cortez, who's the Senior Director of Sales at C&D Technologies. Roel, thank you for joining me today.
Absolutely. Thanks for having me, Doug.
So, I'm really happy that we're able to do this podcast. Of course, as all year long, we've been reporting on AI. But a side topic that I think most people are by now aware of is AI is very energy hungry. It consumes a lot of juice. And there's all sorts of implications, all sorts of impact. Today, we're going to be talking about that from the operator point of view, from the point of view of different strategies, different ideas that you might want to look at with C&D Technologies to handle some of this challenge. We're going to be diving right into that in a second. But first of all, Rob, what is C&D Technologies?
C&D Technologies is a energy storage company. We basically do research and design and manufacture batteries for the different verticals within our industries here in the United States. Telecommunications is one that I am involved in and have responsibility for. But we have a mature product line that's been in the market, in the telecommunications market. It's embedded in a lot of the networks. So we offer those products, again, to the different sectors, from very large scale facilities, telecommunications facilities, to some of the smaller ILAs that we're going to be speaking about today.
So, yeah, let's dive right into it. My first question is, how what are the market trends looking into 2026? I almost feel like I'm asking, how's AI blowing everything up?
Sure. I think the way we look at it, Doug, in the sector and the area of responsibility that I have is there's so many people out there doing the tea leaf reading of what's happening out in the market. You can purchase, reports out there. They're very thorough, but we're a very practical group. And what we do is in the third and fourth quarter of every year, we sit down with our operators, our customers, the people that we sit down and collaborate with and help deploy networks with, to understand where they're going. The name of the game is understand where they're putting their investment, where they see the hotspots for their growth. And in 2026, when I look at it, and again, there's tons of information out there, I look at it in two different categories. One is physical infrastructure, and the other one is intelligence, right? So the biggest deployment we've had technology-wise has been 5G, standalone and advanced, and also fiber expansion. Those are the two that's been expanding the market, and they're going to continue in 2026. 5G standalone is the core. 5G advanced are the hooks that are being used within the 5G core to start as sort of a segue into 6G, which is AI being brought and integrated into the networks to help management of the networks. Fiber expansion, as we know, and we're going to talk about it, that is a hot commodity today because of what's going on in the data centers, what's going on as a society where we're streaming. We live differently today, and everything takes processing power. And then you bring in AI, and that just takes that to a whole nother level. So that's going to continue in 2026. Fixed wireless is another one where we've seen the battle for broadband subscribers. And the operators seem to be winning that game right now because they are quicker. That is their strength zone, and they can deploy those networks a lot quicker. You get out into the rural areas, you're not going to deploy fiber, you're not going to deploy copper. That's kind of out of the question. So fixed wireless, that technology has advanced so much, and it just becomes very efficient, and it's a quick way to hit a market, to deploy quickly into a market. The most interesting one for me, and again, I just have a few in my mind, is the space-based connectivity. And it's basically low orbital satellite networks that are up in the air. And the one that we all know is Starlink that's out there, but there's two other ones that are out there as well. And the idea of having ubiquitous type connectivity anywhere, anytime is not a new concept. It's been around for 15, 20 years, and people have tried to achieve that. But I think the timing is lined up. Imagine just walking out in the market today and you have a handheld, a smart device that can communicate with a satellite and also tie to a physical cell site that can do both as you walk around. The speeds might be a little bit different, but it's there. That's a trend that we see coming. Nobody's going to stop it. And that's going to be a really exciting area. But the last one is not physical, but more on the intelligence, the integration of AI into the operators' networks, right? To help them manage and optimize their network operations. Those are just a few. There's tons, depending on which way you're looking at it, Doug, but there's tons of markets. And those are the ones, the market trends that we're looking at right now.
So, how is AI impacting telecom optical transport?
That's a good question. I look at it in two different ways. When you look at the optical, transport that falls within the telecom network, the number one thing you have to realize is the telecom operators have an immense network in the U.S. Actually, it goes subsea and it goes global, right? So the connectivity. This is something they've been doing. It's their strength zone. They are the backbone of digital society. You'll hear people say that. So you have a group, you have a segment that is very good at doing that. Then you bring in AI and you bring in the hyperscalers and what they're doing at the data centers, right? All this exciting stuff. They need low latency and high capacity because of the intensive AI workloads that require that power hungry gear that they have that requires a lot of power. So you have the group that actually owns the networks that does that very well. You have the problem statement of what they need. And I think what it does when we look at it is it creates a collaborative relationship between hyperscalers and telecom operators, which leads to new revenue streams. And I think the last thing for me, if you let me add to it, the other thing is there's a learning that occurs between a hyperscaler and telecom. The telecom guys had to adapt very quickly and understand that the way they deploy networks is different now. They had to create teams that were specifically working on that. They had to go and sit down and on the supply chain work with companies such as Corning and some of the fiber manufacturers to come up with the latest technology to see how they could deploy it to hit the milestones that we're doing. So there's an enlightenment, I guess is the word I would use for the operators in that collaborative work that they're doing together and a learning that occurs.
So, what are the challenges associated with collaboration between the hyperscalers you were mentioning and the telecom operators?
I think the very first challenge as you take a look at the optical transport is the hyperscalers are speed to market is the most important thing. One of the things when we sit down at the table, Doug, is I preach this to all the sales individuals that we have on our teams is you need to understand the motivation of the individual that's sitting on the opposite side of the table. And in order to do that with a hyperscale, it is speed to market is what they're looking at, right? So that's the number one thing. And the difference between a hyperscale and telecom, the way they do project deployments are really, really, they run at a different pace, if I can say that. The second part and the most important part is because of what we're talking about is this gear that's so power hungry. And now you need throughput on the fiber optics to push it out. You have to rethink the engineering of your inline amplifiers, which is the ILAs, right? So that's a rethinking. You can't address the demand the way you traditionally have engineered and configured those locations to handle optical amplification versus now what they're doing with the wavelength division multiplexing that they're needing. So there's several. There's also the issue when the telecom operators, they have brownfield sites, which are existing sites, and then there's new. And the approach to those is a little bit different, right? To go in and to enhance an existing site, I believe is a little bit more challenging, right? A site that was designed originally to do one thing now at a certain scale now has exploded. And do you start new or do you continue to enhance the site that you have there? The greenfield to me is a lot easier. You sit down with the hyperscalers, you understand scale, and you come up with a configuration platform of how you're going to move forward that can handle the growth, and you kind of move from there. Equipment, I think, when you look inside the huts, the shelters, they're usually 10 by 20, and dimensions are aggregate. Are you going to put multiple shelters together because you need to get more multiplex gear in there? How do you engineer them? And it all comes down to power. It comes down to cooling. And I also think supply chain is another one that you have to look at. So it's not just the technology that's out there. Doug, just so you know, traditionally an ILA, an inline amplifier that was set to handle long transport, was engineered to handle 3 kilowatt rack density, power density per rack, with a maximum of 2, maybe 3. The whole utilization or the support, the design of that gear in those traditional ILAs was just to handle voice and some data. It was amplification, repeat, and regeneration so they can push the signal down the line. We're not talking about that any longer. You have different ways you have to manage that transport of that data through fiber, with lighting it up with the lasers. So it becomes now they're talking beyond 100 kilowatts per rack, depending on what they're doing at those specific sites. If it's a general site or it's a AI purpose-driven site, so your requirements can change. So it's fast. I think that the experience that we've had with some of the folks that we work with, understanding what you engineer for today, will it support 1 or 2 phases of technology? Or do you go way out and engineer for a lot more capacity and it sits idle for a while? What's the right balance? And I think those are the things that are happening in that market. But it's an exciting market. Again, so the power has to be rethought out. The cooling is another one that has to be rethought out, where traditionally an ILA, a telecom ILA, was set up with just what we call DX, expansion cooling, refrigerant type system. Now they're having to bring what they've learned in the data centers with liquid cool and some of those things back out to some level, some scale. So there's a rethinking, and those are some of the challenges that happen between the hyperscales and the telecom guys. The last one I would tell you is supply chain. Believe it or not, there's shortages because they're moving so quickly, and the scale of what they're doing is so fast that again, you have to create a new group, an engineering group. The sourcing has to be different, not 1 or 2. You have to be able to apply it across multiple vendors to try to get consistency, reliability across that network you're deploying. Power is an issue out there, power gear, including batteries. There's also cooling systems that are out there, but the construction piece of it is a major piece of it. So those projects are expanding. They're going to continue to 2023 from what we can tell in the market. It's exciting. And all that to just be able to transport the data center interconnect, the traffic from one data center to another. You have to be able to push it out on the optical network. And so the spillover from what's happening inside the data centers is pushing out into the optical networks.
So as we wrap up our podcast today, you've sort of touched on this idea of intelligent energy storage. Why is that so critical for resilience?
So what I'll tell you on that, Doug, is that everything, all the networks, if you look at all the trends that are out there, again, I said at the very beginning, we look at it from infrastructure and we also look at it from intelligence. Everything is going to a virtualized network out there. You want to be able to throttle up and throttle down traffic as you go. It just gives the operator a powerful tool that allows it to be more nimble to meet the demands, right? The demand that is out with their customers. So all the devices have gone from being passive designs, assets that sat out there, and they were there for one thing, was to give you uninterruptible power when the grid failed. So you had this investment sitting there that sat idle for a long time, except for that one moment that happened very little because the grids are so reliable in the US, have them there. The idea now where things are trending to more in Europe than it is in the US, but it's coming here, it's coming across the pond, is that they're going to intelligent devices, right, where they're more active. And when you look at a power system, Doug, there's really 4 components to make it up. It's the control system, it's the distribution, it's the energy storage, and it's the rectification. The controllers have gone from analog to microprocessors. So you can communicate, and it's like what you and I see, the GUIs, the dashboards are easy to read. that's not where they were in 1980, what they were in the 90s and 2000. They really are advanced. The other element has been the rectification that takes alternating current to direct current. Those devices at one time, you would do a lot of pot adjustments, and it was very discrete components. They're microprocess control. They're plug and play, and when you connect them, there's a handoff, there's an ID, there's a handshake that happens, and information's being transferred all the time. So two elements of a DC power plant are already advanced and are intelligent. And in the last 10 years, maybe 12 years, we've seen where the requirement of the market was demanding that we could actually reset distribution that was out remote. If you look at an ILA, an optical transport, at least long haul, on an average of 60 kilometers, that you have an ILA, an inline amplifier, you'd have to send a tech to go out to reset a breaker in order to turn some piece of gear on. Now they're able to do it remotely with software. So the only thing that's left is the battery, the energy storage. When does it become intelligent? We've learned with lithium, looking at lead acid and lithium incorporates microprocessing in order to manage the internals of the battery, but it also gives you a lot of data. And the question becomes, can you do that with lead acid? The more information they come back, where society, at one time in this market, you would sit down and share with somebody a control system. The first thing they would say is like, that's data overload. That's just too much data. Can you just keep it simple for me? You go down the road now at the same town 3 hours later and have the same meeting. They go, we want every bit of data because we know how to work it, and we can code this up and put a dashboard on very quickly and see what's going on in the network. Everything is tilting in that direction. And I believe to bring in resiliency and to have a cohesive system that learn to become not only self-healing, but self-awareness, looking at environmentals in the ecosystem and taking actions, we're going to need intelligent energy storage to go along with it.
Well, on that note, Roel, I really want to thank you for joining me today to give us a brief overview of this topic. It's a hot topic. I hope we're able to come back in a few months to get an update on how 2026 is actually rolling out, with how those trends are actually happening, and to learn more. I'm going to get you in here to talk about stranded energy. I'm going to hold you to that. So that's a date.
Absolutely. Would love to.
Next time. But because I think that's sort of intriguing. But for now, where can we learn more about CD technologies?
I guess what I would tell you is that at CD Technologies, techno.com is the best place to go, to our website. Everything is there. There's great resources to help you engineer, understand a lot more in detail on the energy, on the batteries that we offer for the different verticals. Again, we have a complete portfolio of products to help assist and support any endeavor, any deployment that the operators are doing out there.
All right. I also put over your head a little barcode where people can click on that and get a little bit of information. Again, thank you very much indeed. This is really cool. We do not do enough podcasts, in my opinion, on energy storage and batteries. I think it's a really hot topic. I think everyone, whatever you're doing, operator, enterprise, channel partner, MSP, absolutely. I think everyone needs to brush up on their knowledge in this. But for now, thanks very much indeed.
You're welcome. Thank you.